Suppose you are working in a pharma industry where they manufacture and pack cough syrup bottles of 150 ml with standard deviation of 2 ml. Now, during the audit time, 100 bottles were picked up and the average volume was found to be 152 ml. Now, the question comes, has mean volume changed from 150 to 152? So, how to find it? We have to apply one sample t-test. So, what to do now? Go to Analyze, click on Compare Mean, click on one sample t-test, select your volume as a variable. Nothing has to be changed. For the test value, let it be 0 because I'm not expecting anything. Then click on OK. It is showing that our mean value is what? 152 with standard deviation of 2.44. What about p-value? It is coming significant, that is 0.000. So we can conclude that yes, our mean value has changed from 150 to 152 ml. We have to use this test when you are having the same group before and after some intervention. This intervention might be some drug intervention and it might be some education intervention as well as per the protocol. Now suppose here we are taking some liver cirrhosis patient for example, and here we are having around 52 individuals with their age, gender, disease duration, pre-test and post-test score. Now suppose I want to check whether patient education or patient counseling can improve patient disease knowledge, yes or no. So what we have done, we have made one questionnaire and we have given to our patient before the patient education and we have taken the score. That is what a pre-test score. And after 2 weeks, we can take again that same test for the patient to check whether that disease specific knowledge is there or not after the education or after the counseling. Then that will be taken up as what? A post test score. So pre test is what? Before the intervention. Post test is what? After the intervention. Now, if we want to check whether patient education or counseling has a significant effect or not on the patient disease knowledge, so what we can do, we can apply pair T test. Why pair T test? Because we are having same group before and after the intervention. Now, how to perform pair T test in SPSS? Go to Analyze, click on Descriptive Statistics, Compare Means, click on Paired Sample T test, and here we are having variable 1 and variable 2. In the variable 1, we can take our pre-test score. In variable 2, we can take our post-test score. Nothing to go for option and bootstrap. Directly click on OK. Now we are getting pre-test score and post-test score. That what you have to report in the table part. So the pre-test score was how much? 13.31 plus minus 2.47. What about post-test? It improved. That means 16.88 plus minus 2.14. Now, whether education has significant effect or not, how to report it? We have to check the paired sample test table. In that part, we are having significant of 0.000. That means patient education or counseling had the significant effect on the patient disease specific knowledge. If someone asks how much score improved after the education, you have to report that 3.57 plus minus 1.89 scores improved after the education or counseling. And this is what we have to report in our table as well, in the paragraphs as well. And this is how you perform paired sample t-test in SPSS. If you are having two different groups and you need to check is there any difference among these two groups, for that part we have to use what? Independent t-test. Suppose in this table, in this data, we are having this case and control. Suppose one is case, two is control, and I need to find is there any difference among the lab parameters. Remember one thing, pair t-test, unpaired t-test, we have to use to compare the means. Paired t-test we are using before and after the intervention, and we are using unpaired for this data in which we are having two different groups. If you are having more than two groups, then we can go with the ANOVA test, but as such we can go with the unpaired t-test or the independent t-test. Suppose again here we are having 1 and 2, one is case, 2 is control, and in the same data we are having some lab values as well, hemoglobin, HCT, RBC, MCV, MC, and so on. Suppose for the learning purpose, let's take only few parameters. So how to perform independent t-test? Click on Analyze, go to compare means, click on third option, that is independent sample t-test. Click on it. Now, in the grouping variables, we have to take data that is in the categorical format. We are having what? Case and control group. So I will shift it here, define groups, as we are having group 1 as 1, group 2 as 2. Here we are having what? Case and control 1 and 2. Click on continue. In the test variables, we have to take all the continuous data. For example, here we are taking some lab values. Suppose I am taking HCT, RBC, MCV and MCH and other parameters as per your interest. Shift over there. No need to go for options and bootstrap. Click on OK. Now here we have the case and control, that is 1 and 2, and we found that mean of 30.54 plus minus 8.80. What about control group? Mean of 28.14 plus minus 7.16. Same we are getting for what? RBC, MCV, MCH, MCHC and other two parameters as well. Now in the table part we have to report what? Mean plus minus ST. So you will take data from the first table. 30.54 plus minus 8.88. For the control group, we are getting what? 28.14 plus minus 7.163. What about the p-value? We will use the second table. Now, in this part, we are getting one more test. That is what? A Levine test. Levine test is used for the variance. So what is variance first of all? How much data is spread. If Levine test is significant, that means p-value of less than 0.05, we have to take equal variance not assumed. If Levine test is significant, that means p-value of less than 0.05, take p-value of what? Equal variance not assumed. Suppose your Levine test is not significant, that is what? P-value of more than 0.05, then we are taking p-value of what? Equal variance assumed, right? Now, for example, in the first part, it is Levine test. We are taking hematocrit, that is HCT. Levine test is not significant. Why? It is 0.207. That means more than 0.05. So we are taking p-value of what? Equal variance assumed. And what is the p-value? Significant two-tail. That is what? 0.138. Correct? Now let me take one more example. Let's take platelet count. Here we are having what? Levine test of 0.011. That is significant because it is p-value of less than 0.05. If Levine test is significant, we have to take p-value of what? Equal variance not assumed. So we are taking what? 0.045, and you have to report this part only. Now in the table part, we have to report mean plus minus ST from the above table, and the p-value will take from where? From the second table. And this is how you have to report p-value for the independent sample t-test. Always remember about the Levine test and which parameter you have to select using significant two-tail part.